Hello, everyone, and welcome to the lectures for Astronomy and Cosmology, which is the last topic of A2. So, this was something which was really a lot in demand by you guys. So, by popular request, here it is. So, I personally have a lot of love for this topic, and not just this topic, but also this entire field of study as a whole, where we analyze all sorts of celestial bodies and planets, black holes, all of that sort of stuff. Because at the end of the day, and I'm sorry if I'm going off at a tangent here, it just goes on to show how insignificant we are in the grand scheme of things. So we say that humans are at the center of everything, and my answer to that is, how can humans be at the center of everything when we aren't even at the center of our own galaxy, right? So we'll be getting to that sort of a debate in a minute. But before that, I wanted to show you guys something, and that will help you build an appreciation of what we are studying, and also why are we studying this thing here. So this right here is a cool app called Stellarium, Stellarium. So not the only app of this type out here, but there are a lot of other apps. This one probably seemed like the easiest one to use for me out of some two or three that I tried. So let's try to first play around with this. So as you can see, there are some options which you can play with here. You can have the grids or lines appear in terms of the longitude and latitude. Let's have the atmosphere first go away. So this is according to some location in the US, and this is how the stars would appear. Right, so I've turned off the atmosphere. It's currently daytime in that part. So I've turned off the atmosphere so everything seems like night. And additionally, I can also turn off the landscape so I can look at all the celestial bodies without having to worry about where the grass pops up. So this is some part of our solar system that we can see here. So this is all of our uh, all that we know about our universe at this moment in time, whenever this video is being recorded, whenever you are seeing this, so that this information is relevant according to that time. So obviously we can see that in our solar system, in our galaxy, we have a lot of bodies. We have stars, we have planets, and we have many other things of the sort. So for example, if I open up a familiar planet to us, for example, something like Jupiter right here. So for Jupiter, I have some information, and then I also have some other distances written here. So I can see that this magnitude is basically its brightness of sorts. Distance, so this is the distance from the Earth, how far this thing is from the Earth. There's something called phase, and there is also the diameter, right? So the problem here is this, or not a problem, or let's call it a question that I want to pose to you guys, which is, how do you figure that how did we come up with these numbers? How did we find how bright or how visible, you can say, such a planet is, and not just Jupiter, but any star or any body for that matter? How did we calculate its distance? How did we calculate its diameter or its radius? So, how do we come up with things like that? And that is what we are going to study in this unit here, right? So, all these questions, and perhaps not all of these, but most of these will be answered in this unit, right? So, Jupiter is a planet. In contrast to the planet, the sun is a star, right? So the only difference between a planet and a star, as you might have also guessed, but let me just put it in technical terms, is this: that a star produces its own light, right? It produces its own energy. The Earth as a planet does not have its own source of light, but Sun as a star produces its energy. And in the previous units, particularly nuclear reactions, we know that this energy is produced by nuclear fusion in the core of the Earth. right? So the earth also produces a lot of energy, which is essential to life at earth, life on earth. And most of this energy is in light, ultraviolet, and in the form of infrared radiation, right? So if we just go ahead onto some other stars, so you can also see that on this app you have some shapes popping up, and then you can see these mystical creatures of sort. So these are called constellations, right? So you see some constellations, some, so this one is called Aquarius, you have Capricornus, and other constellations as well, right? And some of these resemble some sorts of shapes from mythology and legend. So what I want to show you guys here is this. So for example, if I also talk about another star, so Alpha Centauri, right? So this is another sort of a star. This is some star system, and as you can see here, you have the real-time data for its altitude and how it's changing. We have its magnitude as well. Again, the magnitude is just a fancy name for its brightness as seen from the Earth, and we have its distance from the Earth as well. So how did we actually come up with these values is something we'll be investigating the answer to in this unit of ours, right? So you have other stars as well. This is another star. So there are a lot of different types of stars which will obviously be out of the scope of the syllabus. So you also have some star systems. Uh, how are those set up? So sometimes you have stars which form a small system of their own. So there can be 3 or 2 stars usually is what we see in the system, in the universe around us, right? So these are some other constellations. This star is also like a really, really powerful star. This is called Betelgeuse or Betelgeuse, something of this sort. So this one, even though its magnitude, its apparent brightness. So for example, if you're looking at this from the Earth on a really clear night, so this would only appear zero point 0.5 times as bright, but this is a really, really powerful star, right? And this is also a huge star. So if you are interested in this sort of thing, so you might know that the sun, even though it's really large as compared to the Earth, this is in the grand scheme of things, it's called a medium-sized star. So this is actually called, so Betelgeuse is really called a giant star, right? So in terms of its mass, this is really huge. So Betelgeuse is a very, very big star in size, and it is also the 10th brightest star in the night sky. And so this is in the constellation of Orion. So there's a lot of debate about Betelgeuse as well. So people say that it's going to explode in sort of a supernova, but nothing to worry about for us. It will be cool to look up in the sky and see this explosion, but it's really very, very far away to actually have any sort of damage or impact on Earth as well. But again, uh, scientists are proved wrong time and again, so maybe, who knows? Let's see. So you have other things like this, you have Mars, you have other star constellations which are shown, right? So the question that we have to answer, which we'll be looking at in the lectures to follow, is how do we actually calculate these interstellar distances? How do we estimate the radius of stars? And also we know the temperature of some stars, temperature of some planets. So how do we estimate that as well, right? So the answers to all of these questions we'll be looking at in the upcoming series of lectures. So see you there.